Okay, today I will try my best to complete this chapter, okay? So that from the next class, we will start the inverse. So this question we have already done, okay? Next, we will start the questions based on onto function. So who can tell me, Josefa, can you tell me what is the onto function? Josefa, can you tell me what is the onto function? One or more image on B? No, this is not onto. Mazia, can you tell me what is the onto function? No, then Noma, can you tell me what is the onto function? Yes, so Noma, what is the onto function? Yes, if every element of B is have their pre-images in it. Okay, okay, your definitions are also correct. Every element of B is image of. Okay, so first of all, we will again revise that what is the onto function. Then we will see the method of solving the question. Okay, in this topic also you will face the same issue, that how to represent our answer. Okay, so what is a onto function? Suppose we have two sets A and B, and this is a function from A to B. Okay, so A1, A2, A3, A4, and here suppose we have B1, B2, B3. Now suppose A1 is related with B1, here we have A4 also, A2 with B2, A3 with B3, and A4 is also with B4. Okay, so please remember what is the onto function. If all the elements in set B have their pre-images in set A. Okay, what is the onto function? If all the elements in set B have their pre-images in set A, then we will say that this is a onto function. Okay, I hope everyone remember this. If all the elements in set B have their pre-images, so that means suppose if we have a element B4 which do not have its pre-image in A, then this is not onto. Okay, so every element should have its pre-image in set A. So I hope this definition is clear to you. Now please check that how we need to solve this question. Okay, as in relation, we have some standard steps. For reflexive, we have a standard step. For symmetric, we have a standard. For transitive, we have a standard step. Okay, similarly, for this one, for functions also, we have some standard steps to solve the question. So best thing is, please remember the standard statement, because the main difficulty you will face is how to represent your answer. So please, I will write the statement over here. So please learn that statement, and that is applicable to almost all the questions. There are very less questions which we will do by some other method, but in most of the questions you can write that statement. Okay, now for onto function, what is onto? Every element in set B have their pre-images in set A. If anyone have a doubt in onto function, that what is a onto, then please let me know. Okay, because if you don't know what is a onto, then it is not possible for you to solve the question, because in most of the question you need to analyze the expression. Okay, okay, now the first thing is in onto, we will assume a value from the second set. Who can tell me, Atif, what is the R here?
Real numbers.
Real numbers. So here let Y belongs to R. Okay, now you might get confused, or examiner get confused, that from which set you have assumed this value, because in place of set A you have the R, in place of set B also you have the R. So that's why we will always write here. What is this R? From which set we have taken? From the second set B. What is that? This second set B is called codomain. Codomain. Okay. Let Y belongs to R. Okay. So let Y belongs to our codomain such that fx is equal to y. Okay. This implies x cube plus 2 is equal to 5. Okay. Then what you need to do here, you can see you have this value fx is equal to x cube plus 2. Now what you need to do, you need to find x in terms of y. So what we will do, we will shift all the values to the right side. So we will get this one, x cube is equal to y minus 2. Okay, then this cube will be shifted to the right side and this will become cube root y minus 2 1 by 3. Okay, now we will check this here. Who can tell me? Mazia, this is set A and this is set B. If we will talk about this question, then in place of set A, what set is given in the question? Mazia, in place of set A, what is given in the question? Mazia, please reply me on the chat box if you have a mic issue. But I know, that you understand this and you know the answer because you have scored very well in the test. No issue. I guess you have some network issue. Noma, can you tell me in place of set A, what set is given in the question? Real number. Very good. And in place of set B, what is given? Noma. Very good. This is also R. Noma, please tell me that this value y we have selected from which set? From this or from this? From we can say from the domain or codomain. Very good. From the codomain. Okay, so all of you please check here. We have this one, this is R, this is also R. We have selected the value of y from the codomain, from this set. Okay, value of y is selected from this set. Now please check here. We get this expression x is equal to y minus 2 1 by 3. Okay, now we will write like this. First of all, you have selected the y from this is a real number. Now in this expression, who can tell me? Atif, in this expression, if we will put a real number, okay, in place of y, if you will put a real number, then this expression will always give you a real number or not.
Not sure.
Not sure? Okay, no issue. Please remember, in what, so first of all, we will understand that in what cases we will not get a real number. Okay, so we will start from the basics. Natural number. Who can tell me? Huzafa, what's a natural number? Huzafa. Okay, because first of all, you need to understand the concept of real number. Throughout this function, we need that. Huzafa, what's a natural number? Atif, what's a natural number? 1 to infinite. Yes, Huzafa. That's correct. So natural numbers are 1, 2, 3, and so on up to infinite. Next, Atif, what's the whole number?
Natural numbers along with the inclusion of 0.
0. Very good. So this is natural number, this is whole number, and so on. Next, Atif, please tell me what is integer?
What is, sir?
What is an integer?
Integer is whole numbers along with negative numbers.
Negative number. For example, -2, -3, -1, 0, 1, 2, and 2, and so on. Okay, so this is integer. After the integer, we will directly take the real numbers. Okay, I'm ignoring the rational and irrational. So real number. Real number means in the integer, the decimal numbers got missed. If you have a value 1.5, then that will not be an integer. Okay, so that's why we have a real number where we have all the decimal values, all the rational, irrational. Okay, so that's why we always say real number is from minus infinity to infinite with the open interval. This is the real number. When the number is not real, for example, if inside the root we have a negative number, so this is not real. This is what? This is a complex number. You have done this in class 11. Okay, so remember two things. First thing is inside the root, you should not have a negative number. If inside the root you have a negative number, then that will become imaginary. That will not be real. So this is the case when the number is not real. Second, in the denominator, you should never have a 0. Please remember these two cases. Inside the root, you should not have a negative number. In the denominator, you never have a 0. Okay, if you will get a if you will have a 0 in the denominator, that is not real. Please remember these two things. Okay, now root. Okay, root means under root, a square root. What we say, a square root means to the power half. Okay, so that means if you have any even power, okay, 1 by even power, and you have a negative number, then that will not be real. So first thing we have analyzed here that we have a odd power. So that is okay. 1 by 3 is there. So that is okay. So if you will put any value of y, if you will put any real number in place of y, then you will get a real number. So everyone, please confirm me this point is clear. Okay, because in function, you need to analyze some points. So that's why this thing should be clear to you. So please raise your hand if this is clear so that we can proceed forward.
Yes, sir.
Okay, Atif. Everyone else, please raise your hand if this is clear. Okay, Noma. Muzaffar, Saf, Mazia, this is clear?
Yes, sir.
Okay. Muzaffar, this is clear? Okay, very good. Okay, Mazia, very good. Okay, so what we are saying, what value of y we will put here from the set. So we have selected the set as the R, complete real number. So if in place of y we will put any real number, will this expression will be real? Yes, this will be real because we have the even 1 by odd power. If this power will be even, then we will face issue because if the negative number is here, then that will become imaginary. Okay, so we will write like this for all y belongs to R. Okay, again we will say this that we are selecting this from the codomain. For all y belongs to R, y minus 2, 1 by 3 belongs to R. Okay, so we are saying this point for if we are putting any value of y, any real number in place of y, then this complete expression will give us the real number. Okay, so we will write like this for all y belongs to R, that is from codomain, there exist x is equal to y minus 2 power 1 by 3 belongs to R such that, what is this R? From where I have taken this R? From the first set. Okay. I will write this complete statement, then I will explain to you. This for all y belongs to R, there exist x is equal to this belongs to R such that fx is equal to x cube plus 2 is equal to y. So f r to r, fx is equal to x cubed plus 2 is a onto function. It's a onto function. Okay. Now let me explain to you this point again. This value x we will always take from the first set. This value x we will always take from the first set, and the value this y we will always take from the set B. Now what we are saying here, that for all y block, okay, so this point I guess this clear to everyone. This one, for all y belongs to R, this complete expression belongs to R. So what we are saying in the next line, for all y belongs to R codomain, there exists y minus 2 1 by 3 belongs to R. Now what is this y minus 2 1 by 3? This is x. We have already find out here. So we are saying that for all y belongs to R, there exists x is equal to this expression, which belongs to the first set, and this is the condition. Okay, this is the function we have again written here. So what we are trying to say in this statement, that for every value of y, there exists x. That's why it is onto function, and this is the same definition of onto function, that for every value of y, there exists a preimage in set A. Now, okay, so this is a standard statement. From this point, I will write here. Please don't mark this. Okay. So this, and this one. This is standard statement. In every question, you need to do like this only. Okay. You need to find x in terms of y. Then always you need to write this, but you need to analyze the expression, because this depends on this real number natural in this set. So you need to analyze this one. After that, you need to write the same statement everywhere. So please remember this statement for every question. Now, please raise your hand if this is not clear to you, so that I can again explain this. Okay, raise your hand if this is done, because most of the question are like this only. If you understood this, then you can solve the complete questions. Okay, Atif. Okay, everyone please raise your hand if this is clear. Okay, Uzafa, good. Maziha, Noma. Okay, Noma, very good. Maziha, this is clear. Maziha, this is clear. Maziha, yes or no? Okay, Maziha, I got your message. Thank you. So very good. If this is clear to you, please remember the last statement. Now please note down this and confirm me. Then we will start a new question. Okay, so I guess everyone has completed this. Okay, so we will start the next question. Next question is this one. Okay, please try this question and tell me that this is a onto or not. Okay, and one more thing, if you know that this is not onto, okay, the same thing which we have done in relations, if you know that this is not onto, then you can just give a simple example. Okay, you can write that these elements do not have their preimages. I will again discuss with you the concept of image and pre-image. Here A1 is associated with B1. So B1 is called image of A1. Okay, I will again repeat this. B1 is called image of A1 and A1 is called pre-image of B1. Okay, so if you know any value which do not have its pre-image in set A, any value which do not have its pre-image in set A, then you can directly give that example if you already know that this is not onto. The same concept is for 1, 1. If you know any value which is not, for which the function is not 1, 1, then you can just give an example. There's no need to write the complete expression. Okay, so please try the second one and tell me that this is on. First of all, you can tell me that this is onto or not, or you can solve the complete question. Okay, I will give you 2 minutes for this. Seth, you might be facing some issue with this. Okay, so just wait for today. From the next class, we will start the inverse trigonometric function. And one more thing, yesterday I was not be able to take the class. I was not well. So is this possible for you to join today at the same time? It is not confirmed. We will confirm you tomorrow, but I'm just asking from you. It is possible for you on Tuesday at the same time to join the class. Atif, Huzefa,
No,
Musia.
sir.
No, Atif, you have any other class?
Yes, sir. I have the classes during that time 5 to 7.
Okay. Can you tell me what's the timing of your class?
Yes, sir. During weekdays, I have classes from 5 to 7.
5 to 7.
Yes.
Okay, okay, Atif, just give me a minute. Let me check. Okay. In the meantime, all of you, please try to do the second one. Atif, is it possible from 7 to 8:30?
So, 7 to 8:30.
Yep. Is it okay?
1 minute. 1 minute,
Yep.
sir.
Okay, okay. Okay, Sav, this is not on to good. This is correct. So you already know the concept of on 1, 1 and on to, Sav?
Yes, sir.
You already know the concept?
A bit, sir. It
Okay,
was the first lesson my teacher taught me in school.
okay, okay. So you understood this question, the first one.
Yes.
Okay, great. Yeah, this is not on to. Very good. So I guess everyone has done this. Okay, Atif, did you check?
Yes, sir. Sir, Tuesday it's not possible. I think any other day of the weekend I can manage.
Any other day of the weekend?
Any other day of the week, I mean.
Okay, weekdays. Okay, Atif, then I will let you know. Okay. Right.
Okay.
Okay. So second one. Okay. So for the second one, if again we will write the two sets. This is first set. Okay. And this is second set. This is A and this is B. Uh, here we again have the R. Here again we have the R. In place of X, you will put the value from the set A. Okay. If you will analyze like this, fx is equal to x square plus 2. If you can analyze like this, then it will be great, because there is no need to write the complete statement or solving the complete question. Okay. Now, in place of x, we will put the value from this. So real number means every number, negative, positive, decimal, any number you can put. So first thing, Noma, please tell me if we will put a negative number over here in this one. Okay, second is also a real number. That's why we have negative numbers and positive number. 2, 4, 6, 8, 9, anything. Okay, so Noma, please tell me if you will put a negative number in place of x, then what answer you will get, positive or negative? Noma, if you are putting a negative number in place of x, then what answer you will get? Positive answer or negative answer? Positive. So everyone please check here. In place of x, if you will put a negative number, then answer you will get a positive one. If you are putting a positive number, then you are getting a positive answer. Okay, so what the thing is, if you're putting a negative number, you are getting a positive answer. If you're putting a positive number, then ultimately you must get a positive. So that means in the set B, what about these negative numbers? These negative numbers will never have any pre-image in set A. Okay, please check this one. If you will put any number here, you will always get a positive answer. That means, for example, 1, if you will put, you will get a, what you will get? You will get a 3. I will write 3 here. Okay, you will get a 3. If you will put -2 here, then 4 plus 2, you will get a 6. If you put 0, you will get a 2. Okay, so whatever the value you are putting over here, you will always get a positive answer. So that means the negative number do not have the pre-images in set A. So you can directly write this statement. This statement is clear to everyone. Please raise your hands.
Yes, sir.
Okay, Atif. We will write negative numbers negative numbers negative numbers in set B do not have negative numbers in set B do not have their pre-image in set A. Negative numbers in set B do not have their pre-images in set A, hence function R2R fx is equal to x squared plus 2 is not 1. Is not 1. Okay, so if we already know that this is not, sorry, not onto, it's not onto. So if we already know that this is not onto, in such a case, there is no need to assume y or anything else. Just give an example. If you understand this, if you can analyze this directly, then well and good, you can give that example is not onto. Okay. But if you are not able to understand it, then please do in the same way, and then from the expression you need to analyze the final answer. So please raise your hand if this is clear to everyone. Okay, Noma. Okay, Saf. Okay, Atif. Josefa and Mazia, this is clear? Okay, Mazia, very good. Okay, Josefa, very good. So all of you, please note down this, confirm me, then we will try third question. So I hope everyone has done this. Shall we start next? Please start third question. What is a Z in this case, Saf? In the third question, what is a Z? Saf, what is a Z? Function is from Z to Z. You are on mute. Noma, what's a Z in this case in the third part? Integers. Very good. Okay, so please always check the sets. Do not directly check the function. Always take care of the set also, because onto depends on the set also. Okay. So everyone please try this question, the third one, and tell me that this is onto or not. If this is onto, then please try to prove this. Okay. I will give you 2 minutes for this. Please try to solve this in 2 minutes. One more thing, in the second question, I have taken all the numbers. Okay, I have written that negative numbers, all the numbers. But uh, in case the same thing will not came in your mind, then what you can do, you can just give a simple example. Okay, if you are not able to analyze completely, you are not able to find out all the numbers, then you can just give a simple example. For example, here only you can this, or you can also say that -4 do not have its pre-image inside here. That's why this is not on. Okay. Similarly for Z, if you know that this is on not onto, you can just give a simple example. Otherwise, try to solve. Okay, I will wait for your answers. Okay, Noma, if this is, then try to solve it. Okay, Atif, very good. Then just give an example. Okay, if you're not able to find an example, then I will tell you the further method, okay, which we can use here. Everyone, please try to solve this. Okay. Okay, Seth, then please try to do this. Okay, then I will solve this question. Okay, so we are not able to, and maybe we are not able to analyze that this is onto or not. So what we will do, okay, if you have a doubt, then what you will do like this. Again, from the same step, let y belongs to z. What is it? Because both the sets are same. So write codomain. Such that fx is equal to y. This implies 3x plus 2 is equal to y. Okay. This implies shift all the terms to the right side. In left side, you have only x. So this is y minus 2. This implies x is equal to y minus 2 by 3. Okay, so we get this expression x is equal to y minus 2 by 3. Okay, now it is easy for us to analyze. In place of y, okay, so again we will check the concept. Sorry. So we have these two sets and both are integer. Okay, integers start from again same minus 2, minus 1, 0, 1, 2, and so on. And this is. So what you need to do in place of y, you can put any integer and final answer should also be an integer. Okay, because y we are selecting from this and this complete expression is equal to x. So if you are putting any integer in place of y, then this complete expression should always give you an integer. Now, if we will check here, we have many examples, but if we will check example, if y is equal to 0, if y is equal to 0, then what here you will get? Put 0 here, then you will get minus 2 by 3. Then who can tell me, Noma, minus 2 by 3 is an integer or not? No. Okay, good. So if you will put y is equal to 0 here, then you will get minus 2 by 3, and minus 2 by 3 is not an integer. If y is equal to 0 is this, then we can write like this. Just a minute. Then x is equal to 0 minus 2 by 3, which is not an integer. Okay, if y is equal to 0, then this 0 minus 2 by 3, okay, which is minus 2 by 3 is not an integer. Hence, just give me hence this function. Sorry. So y is equal to 0, do not have its pre-image, so hence function f r to r, this one fx is equal to 3x by 2 is not on okay. So you can do this. If from the beginning of the question you are not able to analyze that this is onto or not, then do like this. You will get this expression. Now try to check if you will put in place of y every integer, the answer you are getting is always an integer or not. If you are not getting an integer, then you can say that this is not onto. Please raise your hand if this is clear to you. Okay, Saf. Okay, Numa. Okay, Atif. Josefa, Mazia. This is clear. Josefa and Mazia, this is clear. Okay. Mazia, this is clear. Okay, so from these three questions we have, okay, Mazia, very good. So from these three questions, we have checked all the types of method which we will use to check that the function is onto or not. If these three questions are clear to you, then you can solve any type of question from this slide. Okay, so please, I will give you just 1 minute. So please note down this in 1 minute, then we will try another question. Okay, so everyone please note down this and raise your hand once it is done so that we can start the next question. Everyone, this is done. Shall we start next? Okay, so I hope everyone has done this. Okay, so I'm going to start next question. Now, question based on bijective function. Who can tell me this? Josefa, what is the bijective function? Josefa, what is the bijective function we have done in the last class? All of you, please revise. Yes, if it's both 1, 1 and on to, very good. So the question is, show that the function given, no, this we will do later on. Okay, this is quite tricky. Okay, this is a very good question. This is a signum function. Okay, so what is mean by this? These are very interesting question, but you must know how to analyze it. Okay, now we need to show that this function is given by neither 1, 1 nor onto. They have already said in the question that this is not 1, 1 nor onto. Then definitely we need to give an example. Okay, now please analyze it. Fx is equal to this one. For x is greater than 0, x is equal to 0, x is less than 0. And here they have already defined what first function is r, second is r. Okay, always remember the x you will always choose from the first side. This is r, and this is the second side. This is r. Okay, x we will choose from here. What they are saying, if you are putting a value greater than 0, then what fx you will get 1. So if I will explain to you in this one, here in the real number you will write all the values, minus 100, minus 1000, every value. So I will just write like this, minus 2, minus 1, 0, 1, 2. But you have all the infinite value. You understood this because there is a real number. Here we can put any value. For example, we can put suppose minus 9, minus 1, 0, 1, 2, 9, 10. Okay, check here. show that the Signum function fr to r given by fx is equal to x is greater than 0, then fx is equal to 1. Okay, that means if you are choosing a value greater than 0, then what value of fx you will get? A 1. Then Atif, will you please tell me that if I will choose this x is equal to 1, x we will choose from here. So Atif, if we will choose here, then in the second set, we need to associate this value with which number?
1.
Very good. Again, Atif, next question, if we'll choose this value 10, this will be associated with what?
1.
Good. What about 2?
1.
What about 9?
1.
Very good. So I hope this is clear to everyone, because in the question it is written that for x is greater than 0, fx is equal to 1. So whatever the value greater than 1 is present here, you will associate that with 1. Okay. Now the next question is from Josefa. Josefa, x is equal to 0. So we will associate this with what number? Josefa, we will associate this 0 with what? Very good, Josefa. So we will associate 0 with 0, because in the question it is given that when you will put x is equal to 0, you will get a 0. Now next question is from Seth. Seth, x is less than 0. Okay, so we are taking this minus 1. This minus 1 will be associated with what?
-1.
Very good. Minus 9 will be associated with what?
-1.
Very good. Okay. Now from this only, you can say that this is not on 1, 1. Okay. You can say from this that this is not 1, 1. Because you can say 1, 2, 9, 10. You can write like this. F1 is equal to what? 1. F2 is equal to what? Again 1. Okay, F9 is what? Again 1. So what you can say? X is equal to 1 and 2 have the same image, have the same image, have the same image. Hence, it is, hence it is not 1, 1. Hence it is not 1. Okay, so I hope this is clear to everyone. So you can give any example. Just give a simple example for which this is not true. So you can directly say that this is not 1, 1. On 2. Anyone can tell me how can we show that this is not on 2? We will just give an example. So anyone can tell me?
It's not on 2.
Yes, Sav, that's correct. This is not on 2. So Sav, can you give us an example?
-2
Minus 2 plus 2. Okay, so you can write any value. You can write here like this: -2, 2, do not have their pre-images, do not have their pre-images, hence the given function, hence the given function is not on 2, is not on 2. Okay, you can also write this. If you will see the result, then whatever the value you will choose from this x, result will only be -1, 0, and 1. So that means from the second set, except -1, 0, and 1, any other number do not have their pre-images. So you can write like this also. Okay. So I'm writing this. It's your wish. You can choose any of the answer. Real number except -1, 0, 1 do not have their pre-image, do not have their pre-image, do not have their pre-image, hence function is, hence the given function is not odd. Okay, if you can analyze this, then you can write the second statement also. So I hope this is clear to everyone. So please note down this, confirm me, then we will start the next question.
Sir, can you explain the last sentence?
Yes. Adib, if we will check in the second set, then except -1, 0, and 1, all the other numbers do not have the pre-images. Please check here. -2, 2, any other number do not have the pre-image. Okay, so that's why I'm writing like this, R minus this one. Okay, real number except these number. So from the real number, ignore this, -1, 0, and rest. Okay, rest of the number do not have the pre-image. Hence a given function is not optimal. Clear, Atif?
Okay, sir.
Okay, so it's up to you. If you are able to analyze at this level, then it is better to write the last statement because you have given a proper reply. But in case you are not able to analyze this, then the first statement is also okay. Okay, so everyone please raise your hand if this is done. Okay, no more. Atif, Zafar, Mazia, Saf, please confirm if this is done. Okay,
Yes.
Mazia, good. Okay, Atif, Zafar and Saf, this time. Zephyr, Saf, this time. Shall we start next? Okay, Zephyr. Saf, this time.
Yes, sir.
Okay, very good. Next, there's a very good question. What is a Q in this case? Who can tell me? In this question, Q is given. What is a Q?
Rational number.
A rational number. Very good. Okay. Prove that this function is a bijection. So you already know the steps for bijection 1, 1 and not 2. Please apply the steps. I will give you 3 minutes for this. Then I will solve this question. Okay. If anyone have a doubt, then please let me know. I will solve this. Okay, so please check here if you have already done or if you have a doubt. First one. Okay, first is for 1 1. Okay, so what we always do in 1 1, let we always assume two values. Let x1 x2 belongs to first set, that is q, but again there is a confusion, both the sets are same, so we will write domain. Okay, such that fx1 is equal to fx2. So from this what you will get, 2x1 minus 3 is equal to 2x2 minus 3. Cancel out this, so you will get what, 2x1 is equal to 2x2. So from this you will get what, x1 is equal to x2. Okay, hence fx1 is equal to fx2. This implies x1 is equal to x2. So function f q to q fx is equal to 2x minus 3 is 1 is 1. Okay, so I hope no one should have a doubt in this. Next, second part. Please note down this, then we will start the second part. Okay, second is onto function. Okay, again the same thing in onto. Let y belongs to second set, which is q, so we will write codomain. Let y belongs to q domain such that fx is equal to y. So this means 2x minus 3 is equal to y. Okay, so this implies 2x is equal to y plus 3. This implies x is equal to y plus 3 by 2. Okay, now if you will check a previous question, this one. Okay, here what was the issue? Here the set was an integer. That's why we were saying that minus 2 by 3 is not an integer. But in this question, the question is almost similar, but here we have the set of rational number. Now please check here, in place of y, if you will put any rational number if you will put in place of y, then y plus 3 by 2 will always be a rational. Okay, in that question that was integer, so fraction, decimal were not allowed in that question. But here in place of y you can put any value, the final result, this y plus 3 by 2 will always be a rational. Okay, so you can write the same language which I told you in the first question. For all y belongs to q, for all y belongs to q, this one y plus 3 by 2 belongs to q. Okay, here I will write domain. So just give me a minute. Okay, for all y belongs to q, y plus 3 by 2 belongs to q. Thus, for all y belongs to q, there exists x is equal to y plus 3 by 2, x is equal to y plus 3 by 2 belongs 3 by 2 belongs to q, such that fx is equal to 2x minus 3 is equal to y. Hence the given function is onto. Hence the given function is onto. So we have written the same language which I told you in the first question. Just we have changed the terms. So this is clear to everyone. Please raise your hand if this is clear. If you understood this question, then I hope you can solve any question of this function. Okay, Atif, very good. Josefa, Muzia, Saf, Nova, please raise your hand. Okay, Saf, very good. Josefa, Muzia, Noma, this is clear. So please note down this. Confirm me. If you have a doubt, then please let me know. Okay, and confirm me once it is done. Then we will start our next question. We have right now 50 minutes and we need to solve at least 12 questions today. Please note down this. Please let me know when I need to change this slide. Okay, Noma, onto part, please check here. So for onto, just keep it. Okay, for onto, we will do like this. We have assumed y from the second set. Second is q, which is a codomain, such that fx is equal to y. The same thing, you need to find x in terms of y. You get this value. Now please analyze this expression that in place of y, if you will put any rational number, then this complete expression y plus 3 by 2 will give you always a rational number or not? Yes. Just try to think. In place of y, put any value. For example, put 0. You will get a 3 by 2, which is a rational. Put 1000. 1003 by 2, rational. Put 1.5. You will get a 4.5 by 2, which is a rational. Okay. So in place of y, Noma, if you are putting here any rational number, okay, I will write here. Suppose if you put 1.5 here, you will get a 4.5. So 4.52 is a 4.5 by 2 is a rational number. So that means in place of y, if you are putting any rational number, the result will always be a rational number. Same thing we have written here. Okay, for all y belongs to q, q means rational number. This value is always belongs to q. Okay, so that's why we are writing here. Thus, for all y belongs to q, there exists x, which is equal to this belongs to q, and such that this we always write, so that we will get a relation between x and y. Hence, the given function is onto. So what here we are saying that we have two sets. This is A and this is B. Okay. So y we have selected from here, x we have here. So what we are saying, for every value of y, there exists x, which is onto. This is clear, Noma, now? Very good. So please note down this, all of you, and confirm me so that we can start the next question. This is done. Shall we start next? Please raise your hand. Atif, Zephyr, Mazia, Saf, Noma, please raise your hand if this is done.
Second, show the next page.
Yes, sure. Okay, Atif. No issue. Please message me once you are back. Okay, Mazia, very good. Noma, Saf, Zephyr, please confirm if it is done. Okay, Zephyr, good. Okay, Saf, very good. Okay, Noma, very good. Okay, now we will start the next question. Next is this. This is your NCERT question, and this is also a very, very simple question. Okay, so always please take care of the set. Okay, whenever you get a question, please always take care of the set, because same function can be 1 for any other set. Maybe that is not 1 for natural number. So you need to show that this function is 1 but not onto. Okay, if this is 1 1, you have the standard method, show that this is 1 1. And for they are saying not onto, so give me an example for which this is not onto. Okay, please try to solve this question. I will give you 3 minutes for this. Okay. Okay, so Zephyr, Mazia, Saf, Noma. Please raise your hand if this question is done. Very good, Noma. Zephyr, Mazia, Saf is done. Please check here if this, okay, Saf, very good. Okay, so first is 1 1. The same thing which you always do, 1 1 function. Okay, they are saying that this is 1 1, so they can take the values. Let x1 comma x2 belongs to the first set. Okay, belongs to natural numbers. So in the bracket, right, domain, such that such that Sorry. So such that fx1 is equal to fx. This implies fx1 means 2x1 is equal to 2x2. 2 will get cancelled out. Finally, you will get x1 is equal to x2. You know what statement you need to write. This you can do on your own. So this is 1, 1. Now not onto. Okay, onto function. So Noma, can you give me an example? So please check here. In onto, in the beginning of the question, you know, for example, in the question they have given that this is not onto. Okay, but in the beginning of the question, you are not able to find an example, then do again in the same way. Okay, Atif, very good. So Atif, we are just doing this question. So please check the question. This is a very simple one. Let y belongs to n. N is what? Codomain. Such that fx is equal to y. Okay, what is fx? 2x is equal to y. This implies x is equal to y by 2. Okay, now in place of y put 1. What you will get? 1 by 2. For y is equal to 1, x is equal to 1 by 2, which is not natural number. Which is not natural number. Okay, so that means you have again two sets, a and b. This is a and this is b. B is also natural number. So in B, if you have 1, then 1 do not have its preimage. Why? Because please check this function, fx is equal to 2x. Please put in place of x1, you will get a 2. So that means 1 will be associated with 2. Okay, because there's 2x. 2 will be associated with 4. 3 will be associated with 6. 4 will be associated with 8. So that means 1, 3, 5, 7, 9, 11. All the odd numbers do not have the preimage. Okay, so the same thing I'm writing here. For y is equal to 1, x is equal to 1 by 2, which is not natural number. Hence, the given function, hence the given function is not on. Okay, so all of you, please raise your hand if this is clear. Please raise your hand if this question is clear to you. Okay, Noma, very good. Okay, Atif, good. Okay, Safa, very good. Mazia, Saf, this question is clear. Okay, you have Saf, you have already done. Okay, Mazia, this is clear. Okay, Mazia, very good. So please note down this and then we will start next question. Okay, so today we need to complete this. So what I will do, the simple questions you can do on your own. Okay, so the questions which are somewhat different, that I will do in the class. So I hope everyone has done this, everyone has noted down this. So shall we start next? Is there anyone who is still doing this one? Anyone who is doing this question? So I guess everyone has done this. We will start next. So, okay. I'm sorry, this. Okay, note down this. This is a very simple question. So you just need to give an example. Okay, so this question is noted. Please note down this. You just need to give a simple example for which this is not 1, 1 or. Okay, similar question we have already done. Please note down this. Confirm me. Then we will check the next question. Please raise your hand once you complete this question. Then we will start the next one. This question is only. Everyone, please raise your hand if you have noted down this. Okay, Saf, Mama, Atif, Zephyr, Mazia, please raise your hand. Okay, Zephyr. Okay, Mazia, I guess we have done this. So we are starting next question. Okay, this is also a very, very simple question. This is a homework. Okay, because x cube question we have already done. We have done some question where we have an expression of x cube. So you can do this question. Please note down this homework. Okay, Noma, very good. Atif, Zephyr, Mazia, and Saf, please confirm if this is done. Okay, Atif, very good. Zephyr, Mazia, Saf. Okay, Saf, very good. Zephyr, Mazia, shall we start next? Zephyr and Mazia. Okay, Zephyr, very good. Mazia, this done. I hope you have completed this. Okay. Mazia, please let me know if you miss that question. Okay, Mazia, very good. So this is a very good question. This we will do in the class. Okay. So please check here. Please check this question. Show that the function R naught to R naught. What is mean by R naught? This is the set of all non-zero real numbers. Okay, non-zero real numbers. So that means from the real number, we will ignore the zero. Okay, so show that the function R naught to R naught defined as fx is equal to 1 by x. Defined as fx is equal to 1 by x. This is a function and this is the set. So remember, this is not a real number. We need to remove the zero from the real number. That means non-zero real numbers. Okay. So we need to show that this is 1, 1 and onto both. Okay. So check here for 1, 1. 1, 1. Okay. So 1, 1, we will assume the value let x1 comma x2 belongs to R naught such that fx1 is equal to fx2. Okay, this implies 1 by x1 is equal to 1 by x2. Okay, now 1 by x1 is fine here because I already told you in the starting that in the denominator we never have a 0. Okay, now you will say to me that why this 1 by x1 is defined in this case, because x1 x2 belongs to R naught. R naught is what? All the real number except 0. So that means we are selecting all the real number except 0. So this is defined. This is okay because we will never put a 0 over here because we already said that x1 belongs to R naught. Now 1 by x1 is equal to 1 by x2. This implies x1 is equal to x2. Hence, thus thus fx1 is equal to fx2. This implies x1 is equal to x2 hence the given function is 1 1. Hence the given function is 1 1. Okay. Now next one. Next is onto. Next is onto function. Okay. Now for onto function, what we will do, we will assume the value from the second side. Okay, here we need to write the domain. Now for the onto function, let y belongs to R0, and we will assume this value from the codomain. Okay, let y belongs to R0 such that fx is equal to y. So that means 1 by x is equal to y. Okay, then do the reciprocal both sides. So you will get x is equal to 1 by y. Now please check here. In place of y, you will put every value from R0. What is R0? Again, R except 0. So Atif, please tell me, in place of y, if you will put any real number except 0, then this 1 by y will be a real number except 0 or not?
It will be any non-zero real.
It will be. Very good. Okay. Please check here. In place of y, you can put any real number. For example, you can put 2. Then 1 by 2 is a real number. Put 1.5. 1 by 1.5 is a real number. We will never put 0 because in starting of the question, we have assumed that y belongs to non-zero real number. You can put any value, 1 by 3. So in place of y, you can put any value and the expression will always be a real number. Okay, so then same thing we will write here for all y belongs to R0, 1 by y belongs to R0. Okay, this for all y belongs to R0, there exists x is equal to x is equal to 1 by y naught belongs to belongs to R0. Okay, here right domain such that fx is equal to y, hence the given function is onto. Hence the given function is onto. Okay, so what we are doing, we are just repeating the same steps which we have done earlier. So please let me know if anyone have a doubt in this, because next part I will ask from you. So if you have any doubt, then please let me know. Okay, first of all, note down this, check all the solution, and then tell me the second part. Everyone, please let me know once whenever I need to change the slide. Okay. Everyone, please raise your hand if this is done. Okay, Noma, very good. Please let me, okay, Atif. Muzaffar, Mazia Saf, please let me know. Muzaffar, Mazia, Saf. Okay, Mazia. Muzaffar and Saf, will I change the slide? So please note down this, okay? Then we will check the second part. Okay, Noma, please check here. So Noma, what we always do in onto, we take two sets. Okay, this set A, this is B. So we will always assume y from B and x will be present in it. So what we have done in this case, we are saying here let y belongs to R0. R0 means non-zero real number, such that fx is equal to y. So what is fx? 1 by x. So we get 1 by x is equal to y. This implies x is equal to 1 by y. Okay. Now we need to check that in place of y, if we will put any number from this set, this is what? This is R0. So if we will put any number from this second set R0, then 1 by y will always be a number which is present in set A, that is R0. So we need to check that if we will put any number in y, then 1 by y belongs to R0 or not. Okay, so Noma, please try to analyze this, put any value. Okay, please think in this way. Please put any value in place of y and check. Is there any value which do not belongs to R0? Is there any value which you will get in place of 1 by y that will not belong to R0? No. For example, put 2, you will get 1 by 2. 1 by 2 is a real number. But if y is equal to 1, 1 by 1 is what? Okay, very good question. Then no more. What is 1 by 1? 1 by 1 is 1. So 1 by 1 belongs to R0 or not? Yes. So that means in second set, if you have a 1, then its pre-image is 1 is also there. So that means 1 is associated with 1. 1 have its pre-image. So this is fine. So is there any number Noma in? Okay. Okay. So please note down this. I hope everyone has done this. Now the second part. Okay. I'm going to erase this. You understood the concept. So second part, I will ask from you. What they're saying in the second part, is the result true if the domain R0 is replaced by N? Is replaced by N with codomain being the same as R0. Now, if the domain, if the domain R0 is replaced by n. Now, if the domain R0 is replaced by n, then what the function will become? N R0 with codomain being the same. Okay, so we again need to analyze this. Please check here if you will change the set, then it might affect the function. Function is same, fx is equal to 1 by x. They have changed the set. Then we have this one, n to r0. Okay, so now we will check again 1 function. The same thing, let x1 x2 belongs to n such that fx1 is equal to fx2. This implies fx1 means 1 by x1 is equal to 1 by x2. So natural number, we will never put a denominator 0. So here you will get x1 is equal to x2. Thus, fx1 is equal to fx2. This implies x1 is equal to x2. So the given function is 1 1 is 1 1. Okay. So I hope this is clear to everyone. Okay, 1 1. Now, please note down this, then we will check for onto. Please raise your hand once it is done, then we will check onto function. Okay. I will give you 1 minute for this. Okay, or 30-second may be sufficient. Raise your hand if this is done. Shall we start next? I guess everyone has done this. Okay. Now, okay, Mazir, very good. Now, anyone can tell me that this will be onto or not? Anyone can tell me this is onto or not? We have done a small change.
It is on.
It is onto? Okay. So whenever you have a doubt that this is onto or not, then please use the same method. Okay. Second one, onto. Let y belongs to r0. Okay, r0 is what? Codomain. So we already know now, we have changed the set. So there is no confusion. Let y belongs to r0. Such that fx is equal to y. Okay, what is fx? 1 by x. 1 by x is equal to y. So we will get x is equal to 1 by y. Now, again, we have two sets. This set A and this is set B. Okay. Now, the second set B is what? This is R0. And what is this? This is natural number. Now, you need to put any value from R0 in this expression, and you need to check that 1 by y always belongs to this set or not. Okay. So please tell me, is there any value in set R naught for which 1 by y is not a natural number? Please reply me on the chat box. Is there any value?
Can you repeat what you asked?
Yes, I'm saying, is there any value in second set in this R naught? Is there any value in R naught for which this expression 1 by y does not belongs to the natural number? 1 by y means x. So x lie here. This is natural number. Y is what? R naught. So is there any value in R naught for which this x is not a natural number?
Any value except one.
Any value except one? Perfect. Very good, Noma. 2. Okay. So please check here. In place of y, if you will put 2, if you will put in place of y is equal to 2, then what you will get? 1 by 2. 1 by 2 is not natural number. So that means this is not onto. Okay, so you need to analyze in this way. Previously, this first set was also R naught. So 1 by 2 belongs to R naught. So that's why we have mentioned that in the previous case, it was onto. But here we can say for y is equal to 2, for y is equal to 2, x is equal to 1 by 2 is not a natural number. Not a natural number. Hence 2 do not have its pre-image its pre-image in set A. Hence this given function is not on. Okay, so I hope this is clear to everyone. Okay, or Atif, you can write your statement also that except one, all the numbers do not have their pre-images. Okay. Now, please raise your hand, all of you, if this question is clear to you. Everyone, please raise your hand. Okay, Atif. Okay, Noma. What about Josefa, Mazia, and Saf? This is clear? Josefa, Mazia, and Saf, this is clear? No reply means what? Still have a doubt? Okay, Josefa. Mazia and Saf, this is clear? Okay, Mazia, very good. Saf, please confirm. Okay, and note down this. I will give you just 1 minute for this one. So please note down this. Then we will start the next question. Okay. I hope everyone has completed this. Shall we start next? Shall I rub this? Okay, I'm going to erase this. If anyone is still doing the question, please let me know. Okay, I'm going to erase this. I hope everyone has done this one. Okay, once I will erase this, the data will be lost. There's no option to recover it back. Okay, please let me know if anyone is still doing it. Okay. So, okay, so I hope everyone has completed this. We will start the next question. Okay. Next one. This is also a very, very good question. So still there's some question left. We will continue that in the next class. So in next class, we will solve some questions of functions. Then we will start the inverse because almost the time is done. Prove that the greatest integer function given by this is neither 1, 1 nor onto, where this denotes a greatest integer less than or equal to x. Now, greatest integer function you have already done in class 11. Okay, so I hope you remember that. Anyone can tell me what is the greatest integer function? Anyone can tell me what is the greatest integer function? No. Okay. To remember, Noma, you can tell me what is the greatest integer. You have done last year. Round of real number. Very good. So for greatest integer function, always remember this statement. In this question, this is given, but maybe in some question they will miss this statement. Greatest integer less than or equal to. Okay. Always remember this statement, greatest integer less than or equal to. So what does that mean? Suppose if you have this number 7.9, okay, and you will put in this greatest integer function, then what the value you will get? Greatest integer less than or equal to. So first of all, you need to write all the integers which are equal to this number or less than this. So anyone can tell me any integer which is less than or equal to this? Please unmute yourself.
7.
7. Okay. So 7.9 is not an integer. So any integer which is less than 7.9 or equal to is 7, 6, 5, 4, 3, and so on, infinite. Now from these integer, you need to select the greatest value. So here the greatest value is 7. So the answer is 7. Okay. So always remember this statement, greatest integer less than or equal to. Okay. Now, I hope everyone understood this. We will take one more example. For example, 5.5. So write all the numbers which are equal to or less than this 5.5. So you will get a 5, 4, 3, 2, and so on. Now the greatest integer from these is 5. Okay. Now, Mazia, please tell me this answer 1.3. What is the answer? Mazia, what is the answer of this? This is the last question. Okay, only few minutes are left. Mazia, what is the answer for 1.3? Saf, can you tell me what's the answer for 1.3?
1, 0, minus 1, so on.
Very good. 1, 0, minus 1, and so on. And what will be our final answer?
1.
1. Okay. So I hope everyone understood the concept of greatest integer function. Now we will check that this is 1, 1. Okay. So first of all, we will check for 1, 1. We need to prove that this is neither 1, 1 nor onto. So anyone can give me an example for this? Anyone can give me an example by which we can show that this is not 1, 1?
5.2 and 5.3.
Yes. Perfect. Okay, we will put this value f 2.3, neither 1, 1 and nor onto. Okay, so if you will put f 2.3, 2.3 answer is 2. If you will put f 2.7, again the answer is 2. 2.7, again the answer is 2. So we will say 2.3 and 2.7 have the same image, hence it is not, same image. Okay, I will write here. Hence, it is not as same image. Hence, it is not one function. Okay. Next, we will do for onto function. Okay. For onto, what example we can take? We have two sets, and these are the sets of real number. Okay. So here we have the real number. Here we have a real number. So you must have analyzed whatever the value you will put here, you will always get an integer. Whatever the value you are putting here, but the output is always an integer. That means that decimal value here in this one, 1.3, 1.4 do not have their pre-images. So you can write here non-integral values in set R, that is codomain, do not have their pre-image, do not have their pre-image in set R, that is domain. Hence the given function is not onto. Okay. Or you can give a single example. For example, 1.3 do not have its pre-image, hence this is not onto. So please raise your hand if this is clear to all of you. All of you, please raise your hand. Okay, Noma. Atif, Huzefa, Mazia, Saf, this is clear.
Yes, sir.
Okay.
Yes.
Okay. Huzefa and Mazia, this is clear. Okay, Huzefa. Mazia, Saf, this is clear. Okay, sorry, Saf, you have already told. Mazia, this is clear. Okay, very good. Very good, all of you. So please note down this. And the homework is again the same question which I have given, one question I have given you today, and the assignment which we have already shared. Please try to do this. And in the next class, we will complete all the questions and start the inference. Okay. Okay, then. Thank you. If you have completed this, then you can log off. Okay, Zafar, you're welcome. You're welcome, Noman.
Thank you.
You're welcome, Atif. Okay, sir. So I'm going to end this class. Okay.
Okay, sir.
Okay.
Thank you, sir.